Vanakkam one and all. We will discuss problem number 15 of exercise 5.1. Here they are asking us to discuss the continuity of the function where the function has been defined like this. We will know the domain of the function. So if we know the domain, we can find out the point of discontinuity easily. Now it is going up to infinity on right hand side and going up to minus infinity on left hand side, and I will represent few integers. Okay, now here when the value of x is less than 0, which means for all the values less than 0, okay, the function is 2x, and when the values of x lies in the interval, it's a closed interval actually, so which means you will consider 0 in that and 1 also in the interval. For that the function will be 0, which is a constant function. And when the values of x are greater than 1 from this, okay, up to infinity, we will consider the function as 4x. Okay, so now we will consider the continuity of the function. Now if I take for all x less than 0, for all x less than 0, f of x is equal to 2x, which is a polynomial. It's a polynomial, right? It's a polynomial. Since it is a polynomial, it will be continuous function. F of x is continuous. Or if you want to prove it using the definition, fine, if you can follow that way also. Let me take k less than 0. K is a real number which is less than 0. And f of k will be 2k. And limit x tends to k, where the function is 2x now, it will be 2k. So we can say limit exists and the existed one is equal to the functional value. So the function is continuous. Okay, I have shown the function is continuous for all x less than 0 using the definition. If you want to say the function is continuous in short, you can apply this step where we are stating the function as polynomial function. Since it's been a polynomial, it will be a continuous. Either one of this you can follow either one of this. Now we will check the continuity of the function at x equal to 0. At x equal to 0, what will happen? At x equal to 0, the functional value is 0. F of 0 is 0. Now we'll see the left hand limit. Limit x tends to 0 from left hand neighborhood. So in left hand neighborhood, the function is 2x. The function has been defined as 2x. So we'll get 2 into 0, we'll get 0. And in the right hand neighborhood, limit x tends to 0 plus. When x approaches 0 from right hand neighborhood, the functional value is 0. The function itself is 0, which is a constant function. Get 0. So here left hand limit equal to right hand limit, and this limit is equal to the functional value. So we can say the function is, hence we can say the function is continuous at 0. And we'll consider the interval, the x from this interval. Okay, so let x belongs to the interval 0 to 1. So again here for all x belongs to this interval, f of x is 0 only, which is a constant function. So constant function is a continuous function. It's continuous. Now we'll consider the continuity at point 1. At x equal to 1. When x is equal to 1, the functional value f of 1 is 0, because when the value of x is 1, we are taking the function as 0 function. So here it is 0. Now we'll calculate the left hand limit. Limit x tends to 1 from left hand neighborhood. In the left hand neighborhood of 1, we have the function as 0. F of x equal to 0. Which is 0 only. Now we'll calculate limit x tends to 1 from right hand neighborhood. In the right hand neighborhood, the function is 4x. So 4x, after substituting limit 4 into 1, it is 4. So here left hand limit existing and right hand limit also existing, but those are not equal. So we can say the function is not continuous at x equal to 1. F of x is not continuous at x equal to 1. And when the values of x are greater than 1. When the values of x are greater than 1, obviously the function will be continuous. Okay, so the point 1 is the only point of discontinuity. 1 is the only point of discontinuity. Thank you.